All right, in this set of notes, we're looking at planar graphs. So this is in syllabus topic 6.7, down here with planar graphs. And we've touched on it a bit briefly in class. So planar graphs are graphs that can be drawn without any edges crossing. So graphs drawn without edges crossing, overlapping each other, etc. So the bipartite graph 3,3, K33, cannot be drawn as a planar graph. So not every graph is planar. If we want to draw a planar graph, you should start by finding a Hamiltonian cycle. So find a Hamiltonian cycle. And remember, a Hamiltonian cycle is where we visit each vertex once and return back to the start. We draw that, and we rearrange it if necessary. And then add on the remaining connections around the outside or inside so that no edges overlap. And then draw remaining. So let's look at an example of this. So down here we've got an adjacency table for graph G. I can see that we've got no loops and we've got no multi-edges because all of my degrees are 1. And I also see down here that D and E don't touch. So if I'm going to make a Hamiltonian cycle, I could start at A, then I could go to B. Then instead of going to C next, I'm going to go to D next because I can't go from D to E. So I'll go from D to C, from C I'll go to E, and then E could connect back to A. So if I have A, B, C, D, E, I can connect A to B, B to D, D to C, C to E, and then E back to A. So that's my first step. I'm going to rearrange this, A, B, C, E, D. Okay, and now I'm going to draw in my remaining connections. So A connects to C, is one of the ones I was missing. I need to connect B and D, so B connects to D. So if I tried to draw it this way, it would cross. So instead I'll go around the outside to connect B to D. I also need to connect D to C. Let's see, D to C, yes, and I can do that one on the inside. And somehow, let's see, we've got C to A. Do we have all of our connections? B to E. B to E needs to be drawn as well. Okay, so I think that's all of my connections, and I've made a planar graph based on my adjacency table.